um, review our discussion last Thursday, was it not? And it's all about functions. So be ready with your modules and of course refer the notes to the presentation that you're going to witness today. This is a continuation of our discussion last Thursday. So as a function, as a form of a review, a function is a relation defined by a set of ordered pairs x and y where no two or more distinct ordered pairs of the same first element. Also, every x corresponds to a single unique value of your y. So I gave already a clue to you guys when you're going to see an ordered pairs or a set of coordinates, you have to consider that if you have two values of x with the same value rather of x but different values of your y, then that means it's a mere relation since that same value of x is now having a non-unique value of y, or it contains more than one value of your y, making it a mere relation. So for it to be called as a function, you have to see to it that each x will have to have a single value of y. Even if there are a lot of values of your x, but for as long as all of these x's will only have a single value of your y, then that is a function. So a simple illustration of a function under the tabular presentation we have here below. So these are examples of a function. This is a good example of a one-to-one function. What is a one-to-one function? Later on, we're going to see these. Okay, so if the others are going to do notes taking, I think this is found in your module. I'm not sure, but see to it that it's in your module. If not, you can copy. No? This as well is recorded, so you can review the video later on. Just like the discussion that I had yesterday, it was already uploaded in YouTube. Thus, they can review the video. So as of the moment, you can also make sure your faces are quite presentable so that you will be able to see yourselves in YouTube. No? Let's proceed. So we have here an example of, or another set of uh, domain and range values. So the first set of domain and range to your left is a function. Notice that all domain 3, -3, -2, -1, 0, and 1, they all have the same value of y, which is -6. Even if all x's contains only a single value of your y, which is -6, true to all, still this is considered a function since -3 is paired with only one y, which is -6. Same with -2 paired with only one value of your y, which is -6. Even if it's the same with -3, still all the x's contains only one value of x. If this is somehow interchanged wherein the -6 is in the domain area while all the other values -3 down to 1 will be in the range, then this is already a mere relation, not a function already. But this example is a function. However, the second set of examples, -3 down to 16, -6 down to 15 for the domain and range respectively, these are function except for this part here, which is 16, which doesn't contain any value of y at all, making the whole set not a function. No? So this 16 itself makes this set of values not a function, but simply a mere relation. So we also have here the comparison between a relation and a function. So the relation is a set of values, domain and range, whereas a function is a set of domain and range where the domain is paired with only one value of your range. I highlighted the phrase only, no? So it should be followed perfectly or accurately. We also have here, relation is the relation as a machine gives one or more output, while a function as a machine allows only one output to be presented. As in the case of relation as well, it's a set of ordered pairs. But a function is a set of ordered pairs wherein no two ordered pairs of the same x value. That is what I had been stressing just a while ago, no? Okay, let's proceed. So we have, who did recall the answers to the letters A, B, and C? Which of these are function and which is a mere relation? So A, B, and C are all functions except letter D. Wherein, if you went back to the definition of the function here, no two ordered pairs have the same x value. Please look at this phrase, no two ordered pairs with the same x value. That is in letter D. Ordered pairs -2 and 0, -2 and +2. These are ordered pairs with the same x value. Therefore, it does not follow the definition of a function, making set T under letter D not a function. But all above else, A, B, and C are functions. And then we have here machines. A, this inputs all the letters with each vowel to be having a 5 as an output, with each consonant to be having a 9 as an output, making machine A function. So each of the letters will have to produce a single output, which is either 5 or 9. Machine B is also a function. No? Since if you input any of the numbers between 1 to 10, the output generated will be unique to each of the whole numbers from 1 to 10. Since that number will be multiplied by 0.74, which will generate unique single product of as an output. So that's machine B. Machine C is also a function, since all the letters in the alphabet will generate all the numbers between 1 to 26 will generate a unique value of your y, which is from letters A to letter Y in the alphabet. And that corresponds to what number the letter corresponding to that, if the number, the letter corresponding to that number. So it's like 1, what would be the partner to 1? It's a unique letter in the alphabet. So machine C is a function, okay? But machine E is not a function. Again, machine E is not a function, since for any real number that you're going to input, either the number itself or its negative will be the output, which means that for a real number 2 to be an input, it will generate two possible outputs, +2 and -2. That is now going to defy the definition of a function, wherein a single domain will be paired with only one range. As of this example, machine E will generate two values of your range, the positive value of itself and the negative value of itself. So these are examples of table of values which you're going to compare if and when you have a problem generating the understanding of functions. No, it's just the same as the sets A, B, C, and D, wherein in the first table of values 0, then the one below is -5. You can create from them a relationship, no? It's like an ordered pair x and y. So 0, comma, negative 5. Then comma, parenthesis, 1, comma, negative 4. So looking at the values of x in our first table of values, no value of x is repeated. Same with the second table of values, no values of x are repeated. Therefore, these two set of values or table of values are both functions. And I think we ended up with this activity last Thursday. So we have a jeepney and its plate number. All should you have a unique plate number, making the first example as a function. A student and his ID number. No student will generate the same ID number. So no student as well will have, or no single student will have two different ID numbers, except, of course, if that said student will transfer to another school. However, there's always this idea that if the school being transferred upon by the said student, he or she can use the same ID number from his previous school, provided that that said ID number is not used by any of the student of the said school being transferred from, making the second example a function. A teacher and his cellular phone. This is now a relation, since a teacher could have multiple cellular phones. It could be that teacher Sher Garai could have an iPhone and a Samsung at the same time. Or teacher Edson Son could have Huawei and an Oppo at the same time. That being said, a teacher could have multiple iPhone or multiple phones, making the third example a non-function. This is just a mere relation. Similarly, a pen and the color of its ink. It could be that in a single pen, it could have multiple inks. If you notice, if you can remember way back when you had moments of looking to a store, in particular, National Bookstore, you happen to encounter a retractable pen with multiple colors. There's red in a single ball pen. You have a red, you have a black, you have a, what is that? You have a green. No? That being said, a pen could have multiple color of its ink. Okay, so we are now going to have this. This is a tool for us to understand further what is a function. If a function is now going to be plotted in the Cartesian plane, what makes the graph a function? We have the inclusion of the vertical line test. This vertical line test is literal in its meaning. Okay? Vertical line test is a test for a function that is plotted in a Cartesian plane, and that test will generate the immediate idea if this is a function or not a function. Says the vertical line test should only create a single intersection of the graph being illustrated for it to be called a function. If it generates two or more intersection points, then the graph is not a function. Again, anywhere from the graph. You can draw the vertical line anywhere from your graph. Okay? There are examples here that we're going to draw. This is an example of a function or not? This is a function. Okay? So if you look at it, you draw a vertical line anywhere. Will it be here? Will it be here? Or here? Anywhere from the graph, you will only generate one intersection point. Okay? That intersection point, do not be mistaken, because as you notice, there are 1, 2, 3, 4, 5 intersection points in this graph. But do not be confused about the intersection point. It's between the graph and the vertical line. Okay? One graph to one vertical line. Will it generate multiple intersection points, or will it only generate a single intersection point? If it will generate a single intersection point, then that graph is a function. So if I will to draw a vertical line anywhere of this graph, I will only generate one intersection point. Okay? If we're going to consider this graph then, a graph from Edson to Secret. Now, will I say the name Edson? You saw her yesterday, di ba? You even talked to her yesterday, right? Okay. So if we're going to create a vertical line from this graph, which is the shape of a heart, anywhere except the sides, the left side and the right side, it will generate a single intersection point. Probably that is the point of tangent C. No? This area here and this area here. It will only generate one intersection point or the point of tangent C. But if we draw the line somewhere within the graph. Wait, who is that? Huh? Yes. Okay. If it will be drawn anywhere within the graph here, it will generate two intersection points. Okay. So if I were to draw the vertical line here, the intersection points will be at this area and this area, giving us two intersection points. Thus, this graph is not a function. So, an addition to your understanding of a function, if for example you are given set of coordinates, and for you to know if these are a function set or not, or this is a function set or not, looking at the definition and you cannot foresee if it's a function or not, then graph the coordinates. After graphing the coordinates, connect the dots and then draw a vertical line. Although it's at some point cumbersome or taxing to be done, since it will generate a lot of minutes from your solution time, then don't do it. However, if you are really not sure of your set of coordinates to be a function or not, then graph it. Then draw a vertical line, and from there, you'll get to notice that there are two or more intersection points, then conclude that the graph is not a function. Okay? Then what about the third graph? This one. What is the nature of this graph? In the world of algebra, this graph is a graph of is the graph of a Edson. What do you think? So is this graph? This is the graph of a linear inequality. Okay? The solution set are the ones shaded. Okay? The ones shaded here are the solution set. All values in the shaded area are part of the solution. If without the shade, this is just a linear equation. If that single red line is what we're going to aim for, this is just a linear equation. However, if this is a shaded region, this graph tells us that this is a linear inequality, which means all values of x in the shaded area are part of the solution set. So therefore, is this a function or not? If you draw a vertical line, how many intersection points will be made? Is this a function or not? Let me try. Alan, is this a function or not, Alan? Just guess if you don't know. Nag-chat si Alan. I can see the example. Okay, okay. So what about those who did able to see this one? How about Lucia? May I ask Lucia, is this a function or not?
Function. The function.
It's a function. Okay, please look at this example before I will say the verdict of Lucia's answer. If you are going to draw a vertical line here, all of the points where the vertical line passes in the shaded area are intersection points. Take note that a line is composed of infinite points. To make it a line, it is composed of infinitely many points. Therefore, when the line is drawn on the white area, no intersection point was made. Once it goes beyond the red line, as it goes downwards, it will generate infinitely many points of intersection. Since the line itself is a point, and this area are all solution set, so therefore, the solution set of a linear inequality is not a function. Okay? This is not a function. Okay? When we are going to go back to the example a while ago, let me go back. This one. A parabola that opens upward and a parabola that opens downward are functions. We call these quadratic functions. But what do you think so to the parabola that opens to the right? Parang ganon. Parang siyang less than na drawing. If the parabola that opens to the right and the parabola which opens to the left, they are quadratic relations. They are not functions, okay? They only are simply relations since there are multiple values of y at the same value of x. But here, this is a function. This illustration is a function. Okay, so question so far. Hello, Ma'am Nurse. Morning. Morning, ma'am. Okay, let's proceed then. We have here um, that's the end of the overall viewpoint of a function. The second set of data here that you're going to encounter are the different types of functions. In your module, you have all the array of the different types of functions. Perhaps you need not to take down notes as of this time since what is included here are all but in your module, except for those who haven't received any module at all. May I know who haven't received their module? Alona. So I will send uh, the, the the online copy of this module so that Alona and those who weren't able to get their modules will be able to have the said module through an online copy. If you have a printer at your house, Alona, you can print it. Okay. But if possible, but every Monday, get your modules, all of you guys. Only Alona doesn't have the module. Who doesn't have the module? Except for Alona, may I see? Okay, most of you guys, I believe, took their modules. The one that took the module of Christopher, was that your, it looks really the same to you. It's your father or you yourself?
Father, sir.
Okay. It's like a photocopy of yourself, no? No wonder I was about to call you, I was about to call your dad Christopher. I thought that that was you, no? Anyhow, so aside from Alona, everyone else gets their module. So let's then proceed. The other types of a function, start off, we have a linear function. So what's a linear function, class? It's like the same as the forms of the equation of a line. If you still remember, this is slope intercept form, where m is the slope and b is the y-intercept. Again, the m is the slope and the b is the y-intercept. Always look at this annotation, class, f of x. F of x, or function f of x, simply relates to y. This notation tells us that if x is substituted to the equation, that will generate the value of your y. So f of x is just simply equal to y. So this is a linear function in the form of a slope intercept form. Y equals mx plus b. Okay. We have here examples, I believe. But this example is a worded problem, no? So you're going to find the price of the, what do you call this? What's the problem? To sell the t-shirt, the class needs to charge a lower price as indicated in the table below. So this is the table of the prices for the t-shirt. Let's say, for example, Sean and Josh Ray are dealers of t-shirt. No? They are the owner of Novo t-shirt, and they sell these prices with the number of shirts being sold. This is a relation of the number of t-shirts sold to the price per t-shirt. The number of the lesser number of t-shirts sold, the higher the price. The more number of t-shirts sold, the lesser the price. This is one of the indicators of uh, good bulko business, no? A wholesale business. So tell me the price. The price that you can, which you can sell the t-shirt is called the price function P of X. Let's now going to generate a function, a linear function from the table presented. How we are going to do that? We are going to consider the relationship of 500 and 540 and then create coordinates within them. So target number of sales shirt is 500 will be the X. Price per t-shirt is your Y. May I ask everyone to mute the audio? Unless you have a question, you can unmute yourself. Okay, so let's proceed. So we have here, um, what you have is you're going to generate first the slope using 500 and 540 as your first coordinate, 900 and 460 as your second coordinate. Where did you get these? That's from the table. The first values, 500 and 540, 900 and 460. You can also use the other values, but of course, the first two will always be the first victim when we are going to create our coordinates. So the 500 and the 540 together with the 900 and 460 are your two sets of points that we're going to refer so that we can solve for the value of your slope. Slope formula, we have the rise over the run, or y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. If you can still remember that, no? You had struggles way back in your grade 10 years in Saima old students. We had fun there during those times. Okay, fun seeing your faces to have such a problematic aura. So we have here, assuming that y sub 2 is 460, y sub 1 is 540, x sub 2 is 900, x sub 1 is 500. So we have this y sub 2 minus y sub 1 all over x sub 2, x sub 1 minus x sub 1. And then subtract, you'll get negative 80, and then 900 minus 500 is 400. The negative there is from the 80. Since 460 minus 540 is negative 80. Get the, how do you call that? Get the reduced value, simplified form of 80 over 400, you'll get negative 1/5. We will use the negative 1/5 as your slope. Having had the slope, what else do you need in order for you to solve the equation of the line? You can use any of the other slopes here. Perhaps for those who are acquainted of the forms of the equation of a line, you can just simply generate the equation by using two-point form. No, if you can still remember the two-point form. However, since the solution set that we had in our linear function we have here, it's in a form y equals mx plus b. Okay, so perhaps we're going to use the slope-intercept form. Given that we already have the slope, we can find the y-intercept, or we can use the point-slope form. We have here already the slope, which is negative 1/5. We can use any of the points 500 and 540 together with 900 and 460, any of the two we can use to find the equation of the line. So perhaps we use 500 and 540. So we have here, using the point slope form, this is the point slope form class. Y minus y sub 1 equals m quantity x minus x sub 1. The y sub 1 is 540, the x sub 1 is 500, taken from this point, x, y, x, y. So, y sub 1, x sub 1. So, we have here, in the point slope form, substituting the y sub 1 and the x sub 1 to be 540 and 500, and also the slope to be negative 1/5. Then, of course, what is left for us to do, given the equation and the values being substituted, we simplify. We simplify it by, first, you transpose 1/5, or rather, you distribute 1/5 to x and to 500. So 1/5 times x is negative 1/5. Negative 1/5 times 500 is positive 100. After that, you move 540 to the right. By moving the 540 to the right, it will become positive 540. Therefore, you'll get 540 positive plus 100 is positive 640. From here, you have now the linear function. Y equals negative 1/5 x plus 640. Or you can simply change the arrangement of the values. Instead of writing the x first, you can write the positive value 640, then followed by the decimal part of negative 1/5, which is 0.2x. Pwede ra gyapon na siya, class. Or you can change the y. Since a while ago, the price function is illustrated by p of x, so just simply change the y to p of x, and then just simply copy the right side of the equation. So your final answer is this one. The price function is function p of x is equal to 640 minus the product of 0.2 and the number of t-shirts being sold. For example, if you're going to check if the price function is correct, let's go back for a while. This one. If you're going to have the number of shirts sold as 500, so it will generate 540 as the price per t-shirt. Using the price function, let's try to check, class. You try to multiply negative 0.2 and 500. If you are going to multiply, I hope you have a calculator with you. I am using my cell phone right now. So you have 0.2 multiplied by 500, you'll get 100. So 640 minus 100 equals 540, which is the price of the t-shirt if 500 t-shirts will be sold. To check if your price function is also correct, how about let's try the other values in the said table. So we have here 2,500. Look at the price per t-shirt if the number of t-shirts sold is 25. 140. Remember, 140. So if you're going to use the price function, substituting the x to be 2,500, so 0.2 times 2,500, you'll get 500. 640 minus 500, you'll get 140, which is the price per t-shirt if the number of t-shirts sold is 2,500. Therefore, if this price function will be true to all the examples in the table, then your answer is perhaps correct. Question? Refer again to your module as it is also located in your module for clarification. So to proceed, we have here another type of function, which is the quadratic function. Most books, quadratic function is called parabola. Okay? Quadratic function is also called a parabola. A quadratic function will always have the highest degree to be 2 to make it quadratic. Otherwise, if the x here is equal to 1, or rather, if the exponent of x here is equal to 1, then everything becomes a linear function. So a quadratic function is any equation in a form, function L of x equals ax squared plus bx plus c, wherein the a, the b, and the c are real numbers, and a is not equal to 0. Bakit si a hindi equal to 0, class? Kung si a, mag-i-equal siya ng 0, and then substitute natin dito, 0 times x squared will be 0. If this will be 0, the function becomes a linear function. Get it? So it should not be equal to 0. Otherwise, that is another kind of a function. These are the examples of a parabola that opens upward, which is a function we had in the vertical line test. We did use this a while ago. Then we also have the vertical line test. No, rather the parabola that opens downward. This is a quadratic function. Okay, I think I have a video after this one to clearly understand a quadratic function. After this, I think. The vertex form of a quadratic function uh, is this manner, is this notation. Function f of x equals a quantity x minus h quantity squared plus k, where a is not equal to 0 again. How did we get this form from this one? From this? How did we end up with this form? That, by the way, this is the general form. Please be reminded, the quadratic function ax squared plus bx plus c is the general form of a quadratic function. And this is the vertex form. Vertex form. The h and the k is your vertex. Here. The h and k represents your vertex. How to end up with a vertex form? I'm sure you are familiar with completing the square, but you only will complete the square to the x, not to the y. Okay, so please tell me if my audio or the audio of the video is not so clear, so we will stop looking at the video. Otherwise, if it is quite fine with you guys, the audio, then we'll continue the audio then. Just unmute yourselves and then sir, simply comment, sir, the audio is not good or whatever. Okay? So we have here my favorite university in YouTube, My Y University, who is the sanctuary of myself every time I had difficulty in algebra. Huh? So this is my favorite professor, Professor Von Schmoha. Okay. Okay, is the audio clear?
No, sir.
No, sir. The audio is not clear. I can, sir, I can barely hear. Okay, I'll have a remedy to that. So we'll use the video itself for a while. I will open the video in VLC, and from there we'll get to see it. Okay, so this one. Uh-huh. Is the audio now heard? Not again? Why? Wala pa rin? What? Can anyone tell me what to do with this one? Who is taking this? No. Will I mute myself or what? Audio settings for a while, for a while, plus. Background and filters, audio, suppress use. Suppress background noise. Hi. If this won't work at this time, then maybe we'll proceed without the video then. Let's try again. Comment if the audio is not clear. Can you hear it now?
Not clear, sir.
I'll try to mute myself. So probably I'll just give you the link of of the the video for your own consumption. By the time this session ends, you can look at the video in YouTube. Okay, so I'll just share you the link. Uh, the subs You can subscribe actually to this site in YouTube. We call this MyYU. That's My Y University. It's a recording of problems in mathematics, in particular algebra. That's where I get to understand further the details of algebra, especially if a lesson is not so clearly understood by myself, by the teacher, or by the book itself. No? So go to YouTube, type this one, MY, I'll chat. Type this in the, ano, my, why can't I type? My, yan. You type that, and then it will generate you to the My YU page in YouTube. And then you have here 80, 80 plus videos about algebra, no? All lessons in algebra. This is actually Professor Von Schmoham. Okay, so let's proceed without these slides already. We'll skip this slide, ha? Sayang. Napay ko naman sana to. Okay. So we have the constant function and the identity function. Looking back to the linear function, we have the formula y equals mx plus b, right? So the constant function and the linear function is related to the the constant function and the identity function rather is related to the linear function. It's just that when your slope is 0, that becomes a constant function. If you look at it, b is a constant without any variable, making b a constant. Thus, the function itself, when the slope is 0, is a constant function. Question, if, if it is a constant function and then the slope is a 0, what do you think is the figure of your line? How do you draw that said line? If the slope is 0, making it a constant function. If the slope is 0, your line is, there are only two options there, vertical or horizontal. Sure. If the slope is 0, is it a vertical line or a horizontal line? Dalawa lang yan. Guess.
Horizontal.
Very good. It's a horizontal line. So thank you, Cher. That is correct. The horizontal line generates a 0 slope, since a vertical line generates an undefined slope. And a vertical line, if so you know, is not a function. So therefore, that's your clue already. If it is a function, it should be a diagonal line or a horizontal line. That means a constant function is simply a horizontal line. Anywhere in the graph, for as long as it's a horizontal line, it's a function. There's an activity to test the understanding of linear function being constant and linear function being identity in your modules. Let's proceed with an identity function. If the slope being 0 is a constant function, an identity function generates a y-intercept to be 0, where the slope is 1. So it's just equating y equals x, y equals x, or function f of x equals x. Whatever the value of your x is the value of your y. That is simply to say. Now, what do you think is the graph of a linear function? If the graph of a constant function is a horizontal line, what do you think is the graph of a linear function? Having the slope 1 and a y-intercept of 0. Let me ask. Vince Ehera, since we had this in our problem solving times. Huh? But I think I cannot get, yes, Vince. Hi, Vince. What do you think is the graph of an identity function?
Sir.
Perhaps Vince will type the answer since it's really a problem. Perhaps on my end, you are choppy on my end. So type your answer, Vince. If it's not. So while waiting for the answer of Vince, I'll call another one. Thank you, Vince. You just type your answer, huh? Let me call in.
Sir.
Yes, Vince. Choppy talaga, choppy. So just type your answer, Vince, para hindi ka mahirapan sa kalisod. Okay? Let me call another person. I'll ask Rance this time. Rance, if you do have an audio, please unmute yourself. If not, you can be excused with answering. I think Rance is also having a problem with his connection. But what about those which are good in the connection? Let me call Josh Ray. I call the old students in particular since we had this way back when we are in the grade 10. So Josh, what do you think is the graph of an identity function?
It's a diagonal line.
Which is, there are a lot of diagonal lines. Specify that's a diagonal line. That diagonal line is a half true. So to make it 100% true, specify that diagonal line, Josh. Okay, let me help you from there. It's, thank you, Josh. You're correct that it's a diagonal line. To be specific, the graph of an identity function is a bisector of the first quadrant. It passes the origin. It clearly divides the it clearly divides the first quadrant and the third quadrant. If we look at it in the direction, secondary direction, that's northeast directing to southwest. Going northeast and southwest. No? Okay? So it's like a line sloping upward, directly bisecting your first quadrant passing through the origin. Pag nakita niyo yung function na yan, then that's an identity function. Okay. That's the comparison between a constant function and an identity function. Pag yung slope mo, iba sa bond, pag yung slope mo, -1, linear function na yan. Pag yung slope mo, 2/3, linear function na rin yan. Kahit na yung b 0. Okay? If the slope generates other value other than 1, then that's already a linear function, even if the y-intercept is 0. Okay, another one, or this is an example of the linear and the quadratic, linear identity and constant function class. So give your answer and a reason for your answer. Let's try letter A. Letter A, is this a linear, a constant, or an identity function? Letter A. Having had participated in this session, I wish to ask the new students if you have an idea on letter A. Let me start with Sean. Sean, is letter A linear, an identity, or a constant?
Answer. A linear function, sir.
Very good, Sean. You are then correct. Clap for Sean. So this is a linear function. Okay, letter A is a linear function. Since that is in a form of mx plus b. Okay, how about letter B? Very easy. Letter B, function h of x equals -2. Let me ask Erica. Erica, what is letter B? Is it a linear, an identity, or a constant function? Yeah.
Constant function, sir.
Very good. That is correct. Erica is correct that letter B is a constant function since the range set is only -2, which is a constant. Okay? Very good. So let's have letter C. Can we have Rod? Rod, letter C, Rod.
Linear function, sir.
Again, that is correct. Linear function is letter C is a linear function. So in the three examples, I did not have here any identity function because it's quite obvious for an identity and a constant function. For an identity function, it's just simply x on the right side. For a constant function, it is just a constant on the right side. Otherwise, if it contains any values of your m other than 1, then that is a linear function. So well done. Let's proceed to the other type of a function. We have the absolute value function. Absolute value function contains the presence of the absolute value, the two vertical lines that is going to be present in your um, independent variable, which is the x. The absolute value function can be expressed as well in a compound function. Okay, so the function f of x is an absolute value function wherein it can be expressed in a compound function. This is also called a piecewise function. That's another type of function which we are going to deal later. But the reality of the function here is like f of x equals vertical line x close vertical line. It's like x within the vertical lines. This is an example of an absolute value function. So this is the absolute value notation. Okay, so graph the absolute value function. When you talk about an absolute value class, the absolute value of 2 is positive 2, right? But the absolute value of negative 2 is still positive 2. In other words, the absolute value notation tells us that within the absolute value lies two distinct values. A positive value of this expression and a negative value of this expression. If we're going to generate the piecewise function of this absolute value notation, the likes of this would end up with this. So from here, this one with the presence of the absolute value tells us that there is a negative to that and a positive to that. Get it? Then how come we ended up with 2? How come we ended up with 2, class? From this illustration, we equate this to 0. 2x minus 4, equate that to 0. As in the case of this one. Equate that to 0 and then find the value of x. So 2x minus 4 equals 0. Transpose 4 to the other side, making it 2x equals positive 4. Divide both sides by 2. Therefore, x is 2. This one. Okay? If x is positive 2, what do you think is the value of x inside the absolute value notation? If x is 2 here, substitute 2 times 2 is 4. 4 minus 4 is 0. And the absolute value of 0 is 0. That is why here, for x is 2, the function is 0. This one. Yes? Vince? Someone called my name. Please chat if you have a question. Please do chat. I am also monitoring the chat heads if there are questions. Okay, so to proceed, what if x is less than 2? This notation, if x is less than 2. Okay? If x is less than 2, what are the values of your y? Which is this function. So let's try. Let's try 1 first. 2 times 1 is 2. 2 minus 4 is negative 2, right? So that is why if x is less than 2, this value will generate a negative value. Muna yung buti sa buto ni class. The absolute value notation of this expression where x is less than 2 will generate a negative value. However, if x is greater than 2, 3, 4, 5, 6, 7, 8, and so on, if we substitute that to the expression, 2 times 4, example, is 8 minus 4 is 4, positive. Therefore, this illustration tells us that the two expressions will generate a positive value and a negative value depending on the range of values of your x. There's a difference between an absolute value notation and a piecewise function. Because in a piecewise function, you have two sets of functions. Here, you only started with a single function. You just ended up with a piecewise compound function to generate the understanding that if x is less than 2, all values of your function will be negative. If x is greater than 2, all values of your function will be positive. No? Refer the example in your module. It's in your module. I think there's also another example in your module. I'm not so sure. Oh, my module pala si Alon's. Let's proceed. The instruction was to graph the function. So this is the graph of the absolute value function. In most of the absolute value functions, the graph could either be a parabola, but it's a straight parabola. No? It's like a V or an inverted V. It's like a pyramid. That's the graph of an absolute value function. Notice that we have here a dot as the vertex. This is the part where the x becomes 0. I mean, if the x is 2, y is 0. This is the y, this is the x. Okay. Okay, so to review, we have linear function. Under linear function, we have identity and constant. We also have quadratic function. The quadratic functions seem similar to linear absolute value function in their drawing, except that in a quadratic function, you have the said formula. In the absolute value function, you have a linear function with the presence of the absolute symbol. Okay, so all are actually interrelated. The next one is already the said piecewise function. Piecewise function is a function wherein there are two or multiple more subfunctions. And each subfunctions applies to a certain interval. There is a main function, but we can we can create sub-functions from the main function, from the original function given. So that's what the compound function is all about. And I am already exceeding my time, class. So it's already 8:35. Please refer to your module, the continuation of our discussion today. Okay, continue the function, the piecewise function, and the one-to-one function. Thursday, this coming Thursday, we start with a review of the piecewise function, and then we are going to check your module, the activities there. So that's the piecewise function example class. The constant function 2 and the constant function -5 with the intervals. These are the piecewise function. It's like the same with absolute value again. Related na sila. And then this example is in your module. We are going to deal with this one in our next session. Lastly is the one-to-one function, which is quite simple. Okay. We have to end the session since I'm already over time. Is anyone who wish to raise a question for it to be clarified? Probably that would be on a Thursday now, right? So you are okay if we are going to end the call today?